Let's see this concept, subgroup. And this is very important concept, so understand this. The name itself is telling you. What is the name saying? Subgroup. Subgroup. Subgroup means subset which is a group. Subset which is a group. Under the same operation. Operation you should not change. Under the same operation. So I can say that if you have a group, for example, let's assume you have a group G, star. Then what is subgroup of G? Then if I ask you what is subgroup of G, then what it will be? It will be a subset. It will be subgroup of G. It will be like this. Operation must not change. You should not change the operation. Operation will be same. Operation will be same. Don't change the operation. Operation will be same. But this H is subset of G. This H, this base set is subset of G. So this H is subset of G, and H comma star is a group. Is a group. So this is subset which is group under same operation. So this is the statement. This is the definition. Subgroup means, read the definition carefully, because definitions are very important. Subgroup means subset which is a group under same operation. So under same operation you should not change. Under same operation, subset which is a group. Subset which is a group. For example, let's take some example. Multiplication. We know this is a group. We already know this is a group. We already know. What is the identity element? Identity element is 1. Okay, so this we already know. Now tell me, I'm giving you some subset. Are they group? Which is a are they subgroup? Which is a subgroup? Is this a subgroup? Operation is same. See, most of the time we omit the operation. We omit the operation. Remember, this note you understand. If operation is clear, if operation star is understood, if group operation is understood, if this is clear or if this is understood, then we directly say G is a group. Then what we say? We directly say that G is a group. This statement we directly say instead of saying that G comma star is a group. So basically, if this operation is clear, then instead of saying this statement, we don't have to say this statement. We can directly say G is a group. If this operation is clear, if this operation is understood. Now remember here, which is a subgroup? It is understood. I am asking subgroup. Then automatically it is, what is the operation? Tell me what is the operation? I am asking which is subgroup. So what is the operation? The operation is multiplication. The operation is multiplication. So is this a subgroup? Is this a subgroup? Is this a subgroup? Under same operation. Operation you should not change. You should not change the operation. So which is a subgroup? Operation you should not change. So which of them is subgroup of G? So what is the answer? So see, first of all, this is not a subgroup. Why? Why this is not a subgroup? This is nonsense. Let me tell you. This is actually nonsense. Why? Because you are changing the operation. You are changing the operation because of this. Don't change the operation. If you ask subgroup, then don't change the operation. This option 4 is nonsense. Okay, this is complete nonsense. Next, what about option 3? Option 3, what about option 3? This is also nonsense. This option 3 is also nonsense. Why? Because this is not even a subset. This is not even a subset. Because of this nonsense. Okay, so because of this situation, this is not even a subset. You should take subset. You are saying subgroup. Subgroup means a subset which is group, a subset which is group under the same operation. So you should not change operation, and it should be a subset. This is not even a subset. Finally, this actually makes sense. This is a subset, operation is same, but this is not a group. So this is not a group. Why this is not a group? If you notice, this is not a group. Can anyone tell me why this is not a group? Because this is not closed. Because closure property is not satisfied. You can notice iota multiplied by iota is equal to -1. So okay, this is fine. 1 comma minus, this is a subgroup. So I can say that if you take this structure, if I give you this group G, 1 comma minus 1 comma iota comma minus iota under multiplication, then give me some subgroups. Okay, all the subgroups that you can create, give me, and all the not subgroups that you can create, give me. All the subgroups of G that you can create and all the not subgroups of G. So for example, this is a subgroup, right? I can say that this is a subgroup. Okay, tell me, is this a subgroup? Is this a subgroup? Is this a subgroup? This is not a subgroup. What is the reason? This is not a subgroup because you don't even have identity element. You don't even have identity element. Your identity element you did not take. Your identity element you did not take. So this is not closed. This is not even a group. This is not closed, I can say. And also you can notice that you did not take your identity element. You can also notice that this is a subgroup. You can also notice this G itself is a subgroup. So this is also a subgroup. So you can notice this is not a subgroup. You can notice iota comma minus iota. This is also not a subgroup. This is not closed. And you can notice 1 comma iota comma minus 1. 1 comma iota comma minus 1. What about this? 1 comma iota comma minus 1. This is also not closed. 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 1 comma iota comma minus 1. Because if you multiply this iota comma minus 1, that is minus iota, and minus iota we don't have. So this is the idea. 1 comma minus iota, is this a subgroup? This 1 comma minus iota, this is not even a group. This is not even closed because minus iota multiplied by minus iota, that is equal to -1, and -1 does not belong to your H. So this is the concept is very simple. Yes or no? The subgroup concept. Subgroup basically means that it is a subset which is a group under the same operation. A subset which is the group under the same operation. Okay, let's take this question. So let's assume you have set of integers comma addition. Give some subgroups of this. Can anyone give me subgroups of this? This is also not closed. Okay, let's move on. So how many, which are the subgroups that you can create? The first subgroup that you can create is Z itself. The first subgroup you can create is Z itself. The second subgroup you can create is only take identity element. Only take identity element. This subgroup you can create. The next subgroup you can create is all the even numbers. All the even numbers. All the multiple of 2. 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 All the multiple of 3. All the multiple of 4. All the multiple of 5. All the multiple of anything. Let me tell you one more thing. So what these symbols? Okay, so just understand these symbols. Just wait. Do you remember this symbol? What is Z and this symbol? This means 0 to n minus 1. This is the symbol. Let me tell you, some people use this symbol and some people use this symbol. So both are same. Some people use this symbol, some people use this symbol, but both these symbols are same. In the GATE exam, they will give you this in the GATE exam. Okay, in the GATE exam, they will not use these symbols. They will give you the exact thing. If you check all the GATE exam questions, they will not give you this symbol. They will not give you this symbol. But authors use this. Okay, many authors, they use this symbol. So for example, if I ask you what is Z4, then authors, what they will do, some authors will use this symbol. And both of them means 0, 1, 2, 3. Okay, so this is the idea. If you are reading any book and you see this symbol, then it automatically, okay, you can check it out. It will be this. If you read this, if you see this symbol. But don't worry, this is not required for GATE. Anyway, okay, remember, not needed for GATE. You don't have to worry about these symbols and all. Now let's see this one. And one more symbol is used. If I directly ask you what is 2Z, what do you think? What is your intuition for 2Z? I'm directly asking you 2Z. What is your intuition? It means multiple of 2. It simply means multiple of 2. It simply means that all the multiple of 2. So basically, this 2Z, this simply means all the multiple of 2. Integer multiples of 2. Or I can say this is your set of even numbers. Similarly, you can define nz. What is nz? That will be nx, where x is integer. That will be multiple of n. So this nz, this simply means multiple of n. So these symbols, these are just some little bits. Okay, so these are different. Remember, if I give you 2z and if I give you this symbol, these are different. These are different. This means even numbers. This means all even numbers. So it will be like 0, 2, minus 2, 4, minus 4, and so on. And this will be what? This will be what? This will be your Z2. This will be your 0, 1. Okay, so just understand that this and this, they are different. Okay, this symbol means nz. Nz means 2z means multiple of 2. Very simple. Very easy to remember. 2z means multiple of 2. 3z means multiple of 3. 4z means multiple of 4. And this symbol, this fancy symbol, okay, this fancy weird symbol, this is same as this. It means Z2. So you can just understand that this is your Z2. And Z2 means this you already know. This is 0, 1. Okay, let's come back to this question. So you have set of integers, plus. Now you can check it out. For all n, this is a subgroup. Yes or no? If you notice, this is your Z, plus. This is your group. And for all n, what will happen? For all n belonging to set of integers, nz is also a subgroup. Is a subgroup of Z, plus. For example, if you take, like, for example, let's assume you take n equal to 4. Then what will you get? Then you will get 4z, plus. And you can notice that, first of all, this is a subset. First of all, this is a subset. Second, this is the same operation. Second, the same operation. So this is a subset and also this is the same operation. And you can notice this is a group, right? And you can notice this is a closed because all are multiple of 4. Everything is multiple of 4. So this is closed. And you have identity element. Identity element is 0 because 0 is multiple of 4. And you have inverse also. For example, tell me what is the inverse of any element? If I give you what is the inverse of 4n? That will be minus 4n. Okay, so you can notice, and this addition is associative. You already know this is associative. So this is a group, you can notice. Same operation, subset, and also this is a group. So I can say this is a subgroup. Is this clear? What is a subgroup? What is not a subgroup? Is this concept clear? One interesting question. If I give you this group, so let's assume G is like this, Z comma plus. How many finite subgroups you have? How many finite subgroups of G? How many finite subgroups of G you can create? How many finite subgroups of G you can create? The answer is only one. Only one finite subgroup you can create. This is that. Nothing else will be like whatever else you create. That is not a subgroup. That will not be closed. Whatever else you create, whatever else finite you create, that will not be closed. So how many finite subgroups of G are there? The answer is one. Only this one. Okay, anyway, let's come back to this question, this definition. What is a subgroup? So if you have a group G comma star, then subgroup is a subset. Subgroup is a subset such that you can notice one thing, that identity element you should take, right? This is the idea. This is the idea. See, if you have a group, let's assume you have a group, and because it is a group, so you have identity element A1, A2, and so on. And this is your operation. Now, how to create subgroup? Tell me how to create subgroup of G. How to create subgroup of G? You should take identity element because you want a group. Subgroup is a group. This is a subset which is a group. This is a subset of G which is a group. Under operation star. Okay, so you can notice if you want to create a subgroup, then definitely you should, first of all, you should take E. Directly you take E. Without taking this E, there is no point. This is the first step. Directly take identity element because you want to create a group, right? This is the point. If you want to create a group, then you should directly take identity element. This is mandatory. So it should happen. So identity element, definitely it should belong to subgroup. Now, just remember one more thing. If I take, let's assume if I take A1, then what should happen? If I take A1, then what should happen? I should also take A1 inverse. If I take A1, then I should also take A1 inverse. So this is the idea. This is how you create a subgroup. And remember, if I take A1, then because of A1, what things will come? Because of A1, what things will come? Because of this A1 square also will come. Why? Can anyone tell me why A1 square will also come? Because of closure property. Because of closure property, A1 square also should come. Because of closure. So you can notice, if you take A1, then automatically because of this A1 inverse will come. Also A1 square will come. What about A1 cube? What about A1 cube? See, if you have A1 square comma A1, then of course A1 cube also will come. Because of these two, A1 cube also will come, right? See, because of this will come. So because of A1 square will come because of closure property. Because of this and this will come because of closure property. So A1 cube will come and so on. So these things will come because of A1. Can you notice? I'm just telling you all the things that will come because of A1. Because of A1, all these things should come. This is the idea of creating a subgroup. Is this clear? So you should take identity element, and if you take A1, then you should take all these elements. Okay, so this is the, remember, this is the idea to create subgroup H of G. Okay, the first idea is just directly take identity element, of G in H. The second idea, if you take A1, in H, remember, if you take A1 in H, then A1 inverse also should come, A1 square also should come, A1 cube also should come, all these things should come, A1 power 4 also should come, all these things should be taken, This is taken because of closure property, because of closure property, these are taken, and this is taken because of inverse property. Is this clear? See, for example, let's assume that you have this group. Now I'm creating a subgroup. Now let's see how to create subgroup. Then what is the first step? If I want to create any subgroup, then what is the first step? I should directly take identity element. This is the first step. Always take identity element. Now let's assume I take 3. Now let's assume I take 3. So this is mandatory. Now let's assume if I take this, if we take 3, okay, then what will happen? If we take 3, then what will happen? Because of closure property, see, if you are taking 3, then it means, can I close it here? Just think about it. Okay, if I take 3, then can I close this here? Can I say this? What is the problem? Please tell me what is the problem. Can I close this? What is the problem? Closure property is the problem. If you do this, then because of 3 plus 3 will be there. Where is your 3 plus 3? 3 plus 3? 3 plus 3 means 3 square. So if we take 3, then I have to take 3 square. Now because of these two, I have to take 3 cube. Remember, 3 square is 6. Remember, 3 cube is 9. Anyone has any doubt why we are taking a square, a cube? Why we are taking all these? A square, a cube, a power 4. Why we are taking all these? Because of closure property. If you take 3, then 3 plus 3 should be there. This is your 3 plus 3. This is your 3 plus 3 plus 3. Similarly, 3 power 4 will be there. Similarly, 3 power 5 should be there. And so on. 3 power 4, that is your 12. 3 power 5, that is your 15. And also, 3 inverse must be there, right? What is the 3 inverse? I should take 3 inverse. What is 3 inverse? 3 inverse is minus 3. So I should take minus 3. And if I'm taking minus 3, now what will happen? If I'm taking minus 3, then what will happen? Then minus 3 whole square also should come. Minus 3 whole cube also should come. If I'm taking minus 3, then minus 3 whole square also should come because of closure property. Minus 3 whole cube also should come because of closure property. So I hope this idea is clear. Okay. So any subgroup that you create, any subgroup that contains A. What is the subgroup that contains A? What will be a subgroup that contains A? What that will be? So subgroup that contains A, it should contain E. There is no choice. This should mandatory. This is mandatory. whatever subgroup you create, this is mandatory. Now subgroup that contains A. So if you are taking A, then you should take A square, A cube, A power 4 and so on. You should take, because you are taking A, so you should take A inverse, and because you are taking D, so you should take D square, D cube and so on. Yes or no? Because you are taking D, so you should take D square, D cube and so on. So this is the idea. Is this clear to everyone? So this is the definition of subgroup. Subgroup is a subset which is a group, means identity element must be there, closure property must be there, inverse property must be there, and you don't have to check associative property. Can you notice? Do you need to check associative property? Do you need to check associative property? No need to check associative property, because already this is associative, so that operation is already associative. Just tell me, actually one of them is redundant. One of them is redundant. Which is redundant? These three properties, one of them is redundant. One of them I can remove. One of them I can remove. Which can I remove? I can remove this. This first one I can remove. Because if I have inverse, because of property number 3, automatically property number 1 will be there. Array, because of property number 3, automatically property number will be 1 will be there. Yes or no? This property number 1 is redundant. But if I remove this, then I have to say non-empty subset. If I remove this property, then I have to say non-empty subset. Let me tell you the reason. Because property number 3 automatically implies property number 1. This is what I'm saying. See, okay, just understand this one. This is a note. Any non-empty, this is important, any non-empty subset H of group G. Okay, so this statement, this is a, or maybe this is a question, I can create this as a question. You take any non-empty, this non-empty word is important, any non-empty subset H of group G which satisfies these two properties. So two properties I am giving you. Okay, for all A comma B, which satisfy for all A comma B in H, for all A comma B in H, closure property is satisfied and inverse property is satisfied. So if this will happen, then I can say identity element belongs to H. Can I say identity element belongs to H? Tell me. Let's prove. Any non-empty subset, you take any non-empty, this is non-empty, this non-empty is important. So if you take any non-empty subset H of group G which satisfies these two properties, means this H is closed, this means H is closed, and this means A inverse is there in H. Now can I say that E will be there? Can I say identity element E will be there? And the answer is yes. The answer is yes, because you can notice H is non-empty. This is the proof. The proof is very simple. Since H is non-empty, right? Because H is non-empty, so you have at least one element. So there exists at least one element in H, right? Agree? Agree or not? So there is, because this H is non-empty, so there is at least one element in H. In this H, there is at least one element. And now you are saying that for every element inverse is also there. Okay, so A inverse is also there in H. You are saying that for every element A inverse is also there in H. So you have inverse also. Now from this, so what can I say? So I can say because of closure property, you are saying that closure property, you are saying that as H is closed, you are saying H is closed. So what it means? It means E also belongs to H. So that's it. Is this clear? See, H is non-empty, so there is at least one element. And you are saying that its inverse is also there, so its inverse is also there. And you are saying that closure property is satisfied. You are saying closure property is satisfied. So I can say yes, identity element will be there in H. See, you are saying that you have a non-empty subset. You have a non-empty H. You have a non-empty H, which is subset of G. You have a non-empty H. And you are saying that H has two properties. H has two properties, closure property. What you are saying that it has closure property. This is closed. And this has, okay, for all A, inverse is there. And A inverse exists for all A. For all A in H. Okay, A inverse is here. So from these two, you can clearly see what will happen. So because of non-empty, you have at least one element. And because you have, for every element in H, you have A inverse. For every element in H, you have A inverse. And because of this closure property, I can say that this also will belong to H. So because of this closure property, this also will belong to H. So anyway, the point is very simple, that only two things you have to check, that it should be closed. You should have closure property, non-empty subset which is closed, and also which has inverse. So these two things you have to check. In Z9 under addition, this is under addition modulo 9. This is addition modulo 9. Okay, this will form a proper subgroup. What is proper subgroup? What is proper subgroup? Tell me. What is proper subgroup? H is subgroup and H is not equal to G. H is subgroup of G. H is subgroup of G. And H is not equal to G. Means other than G. Any subgroup other than G itself. Any subgroup other than G itself. Okay. It should be a subgroup, but it should not be equal to G. So proper subgroup means any subgroup other than G. Because you already know that G is subgroup of itself. You already know these properties. If you take any group, G comma star, if you take any group, then two things will happen. What are the two things? Two things will see. This is always a group. This is always a subgroup, right? This is always a subgroup, correct? So this G itself means this is subgroup of itself. This G, this is subgroup of itself. And another is, just take identity element. This cute group is trivial group. This is known as trivial subgroup. This cute group, you can notice, very cute. Just take only identity element. Only identity element you take. This cute group is called trivial subgroup. Okay. So for any group you take, then this will be a subgroup. Also, this will be a subgroup. These two will be subgroup of every group. Any group you take. This G itself is subgroup of itself. Every group is subgroup of itself. And also this is subgroup of every group. Just take identity element of G. From this G, you take identity element. And proper subgroup means any subgroup other than G. So remember, this is a proper subgroup. Okay, so you can notice that this itself is a proper subgroup. This is also proper subgroup. Okay, so any subgroup other than G. This Z9, you already know. This Z9. So this Z9 under addition modulo 9, you already know this is a group. This is a abelian group. Can I say this is a proper subgroup? Tell me, can I say this is a proper subgroup? 0, 3, 6, addition modulo 9. Just check it out. Is this a proper subgroup? You can notice, yes, this is proper subset. Yes, this is proper subset. But can I say this is a group? 0, 3, 6. Is this a, yes, this is closed. You can notice this is closed. Any two elements you take, this is closed. And you can notice identity element you have taken. and you can notice 3 inverse is 6, 6 inverse is 3. So every property is satisfied. You don't have to check associative property. No need to check associative property. Okay, never check associative property. Just check closure property. You check identity element is taken, closure property is satisfied, and also every element has inverse. So I can say this is a proper subgroup because it is not Z9. This is a proper subset, which is a group.